automotive, a series circuit is a very simple circuit, generally good for one individual circuit. However, our most common ones in automotive are the parallel circuit. And the reason is because we can have one source voltage, but we can have two or more individual circuits. Now, the reason we call this parallel is because they obviously run individual of each other. And how do you know they're individual of each other? We have a power source, we have the wiring, it has its own load, and it has its own individual ground. So, take for example, if this was your running lights or your brake lights. I don't know how many cars in Hemet have one brake light on, but the rest of them are blown out. If it was a series circuit, if that light blew out, nothing in the circuit would work. So for example, if that was a brake light and that was a brake light, if one blew out, none of it would work. A parallel circuit is different. If this light bulb blew out, this one would still function because it has its own power source and path to ground. However, the way we calculate Ohm's law is considerably different between the parallel circuit and the series circuit. So here we have voltage coming from the power supply down through its wires to the load. Let's see, the light bulb will come on and it will travel to ground. Same with the second circuit right here, and for however many circuits we have after that. In order to figure out a parallel circuit, you still use Ohm's law, but you'd have to figure out the total resistance of the circuit first. And you don't just add them up like you would in a series circuit. They're different. We have to use a different kind of calculation. So there's about 3 of them that I like to use because they're simple. We have, this is probably the hardest, but we'll get to that one later, so don't worry about that yet. One of them is, we can simplify the whole process. And when I say simplify, if you look at, we have 2 legs, and both of those legs have the same amount of resistance for them. So does 2 go into 4 evenly? Yes, it does. So how many times? 2. 2 goes into 4 twice. So the RT is 2 ohms. And we'll use that as we go through the rest of the calculations. Another way to do it is you would find the amperage of each leg. Right here we have 4 ohms. 4 goes into 12 3 times. So that is a 3 amp circuit. 4 goes into 12 3 times. So both of those legs, because they have the same amount of resistance, have the same amount of current in them. Oh, amazing. I can turn my phone sideways. Now you just add those up. 3 amps plus 3 amps equals 6 amps. So this total circuit is 6 amps. And the reason why we add them up is because it starts with a single line. And from there, that wire will split into their own paths. Now, if this was a different amount of resistance, then this amperage would be different, of course, and we'll get to that later. So now we have a 6 amp circuit. Now you just do Ohm's law. If we know the amperage and we know the voltage, we can figure out the resistance by doing what? Dividing. So 6 goes into 12 2 times. Ta-da! So that's the second method I like to use. Now for the hard one. No, it's only hard because you have to add and do some math. So this is called the reciprocal method, and it's R1 times R2. Hopefully I didn't get them backwards because I usually do. So resistor number 1 is 4. Resistor number 2 is 4. And then you divide that by 4 plus 4. Do the math. 4 times 4 is 20. No, that ain't 20. 18, right? 12, 13, 14, 15, 16. And no, I don't have a calculator because I'm using my phone. 4 plus 4 is 8. 8 goes into 16. 2. The RT is 2. So each of those methods that we used to solve the Ohm's law of this circuit worked out. Now if we do a voltage drop, it's the same thing as if we were doing it on a series circuit. How much voltage is going to drop across this one? 4 into 12. Sorry. Yeah, 12 is, now we want ohms into amps to figure out our volts. 4 goes into 12.